in was to explain to him that, this could basically be the electronic ankle bracelet for bad diverters. And so the box you're looking at here, so the little horn-shaped thing, I don't know if you can see my cursor, that is a sonar that's, if you go to almost any wastewater treatment plant, they gauge their flow going through their wastewater treatment plant with the ultrasonic distance measurer and a partial flume. And the distance measurer gives you stream stage, and the flume just gives you a nice control section. So this is inside of the guts, and so it's quite amazing. I wish I'd put something better in there for scale. This is about the size of, say, a hamburger box you might get from McDonald's or Burger King. And the very center of it, the green, well, kind of hard to make out on the screen, but this little green box here, this is a cell phone connected microcontroller. It's called a multi-tech Dragonfly. And then these are all the sensors we have plugged into it. See the sonar, temperature, and charge power going in. This is our cutting edge fabrication facility, otherwise known as my kitchen table. And this is our very high-tech calibration and testing facility, otherwise known as my guest bath. And so, to get to really why this is important, so we think that there's an intricate marriage between water quantity and water quality. And so, TMDL processes have been going on for a long time. I'm somewhat optimistic that maybe the drought will go away and we stop being just focused only on water quantity, and we start to look back at the interplay or the synergy between water quantity and water quality. And so, TMDLs have a problem statement, then they develop numerical targets, then they go through a bunch of bickering. Went to a meeting a couple of months ago, water board meeting. They're actually proposing a 0 sediment load for the Elk River, which I thought was a courageous but turned out to be doomed effort in terms of the board, basically not approving of the staff's recommendation to have a 0 waste load allocation for sediment in Elk River. And the whole idea was it's already choked the sediment, so how can you put any more in? And so we think that by getting better data, we'll be able to, maybe work our way around some of these issues with TMDLs, or at least be able to inform TMDL decisions and assure that they're either working or they're not. And so, the 303D list is kind of both a demonstration of what's awesome about the Clean Water Act and also what's kind of flawed. So the Cuyahoga River no longer catches on fire. Now we only have rivers catch on fire when oil trains get derailed into them. On the other hand, we do have substantially better water quality conditions, throughout the country, but we still don't have a good handle on whether we're reaching water quality objectives or not. And so the non-point source loads are cyclical, like my failure catastrophe, and it's not really a daily load. So what we really want to do is create a tool that's affordable for people to either look at water quality problems and to deal with water quantity problems at the same time. And so, we've really adversely affected our watersheds in terms of their ability to hold on to water through a number of measures, So, most basins are over allocated, at least seasonally. They've tried to add the nexus between flow and water quality with a policy for maintaining in-stream flows in Northern California coastal creeks, and I'll call that the PMISF later, and also with the WDRs for cannabis and making people kind of go to a storage and forbearance mode. We also need a means to coordinate and monitor water diversions. I've been to a number of creeks, so you go out there at 8 o'clock in the morning and there's no water, and because everybody woke up and decided to turn on their pump and fill their tank, and then you go back out there at noon, it's like, oh, there's a trickle, and you get back out there by 6 and it's flowing again. And so we really see this need to sequence diversions, especially as we see this declining summer low flow condition. And so both the US EPA and Cal EPA recognize the problem of us basically turning all our streams into freeways and major arterials. One of my projects I'm really happy to have been involved with was Baker Creek, where we came in and put in a bunch of channel spanning log features, trying to get the channel to a grade, trying to get the bank storage back in, and it's been successful, but I think it's for a different reason. I don't think it's necessarily because of the hydrology. I think it's actually because of the nutrient cycling. And so, you know, there's a lot of LID requirements in current codes that require you to try to put more water into the ground. This problem was really first noticed back when I was working at the Regional Water Board down in the Bay Area, where the Zone 7, Alameda Zone 7 Water Agency started seeing their groundwater elevations going down and down and down. And then they're like, oh, we paved the entire recharge area for our watershed, huh? And so they turned it into an impermeable surface, and thus, you know, the groundwater recharge and the discharge to streams, you know, was really adversely affected by us, you know, creating all these impervious surfaces. LID stands for low impact development. And so the governments, you know, and the state have funded and supported a lot of watershed restoration projects. There is an effort to increase enforcement of illegal diversions. Most of us in the government are realists about climate change and realize that we might ought to call it what it really is, and what might be more scareful to people, which is, you know, hydrologic change. And so, you know, it's kind of funny that Texas, where I lived from age 8 to 18, is now having floods like every month that are like setting new records for them, even though they're kind of the epicenter of big oil and, you know, a reason why the climate's changing a lot. And then if you look at the 303D list itself, there's lots of public comments that like, you really ought to list, you know, the Navarro River for flow. Well, flow is not a pollutant, so it really can't fit on the 303D list. The other thing that's important to note is that USGS has typically put its gauges in to adjust or to measure for peak flows rather than for minimum flows. And so we realize there's a need for a tool to do that minimum flow monitoring. The other thing, it's, you know, even kind of sad to this day, you know, we have been talking to the state board quite a bit, both to the water quality and the water resources, water rights side, and they still act as kind of quasi-independent agencies. And, you know, there's that famous quote, you know, out west, whiskey's for drinking and water's for fighting over. You know, for so long, especially during my period of observing the Department of Water Rights, is they were really, you know, chronically understaffed, and it's because nobody really wanted to have their diversions regulated. They wanted to be able to, you know, live in the Wild West and take as much water as they could. And so the policy for maintaining in-stream flow was like really the first opportunity for California to lower quantity. And I thought it was like a, you know, it was a new day when that policy got passed. It got shot down or, you know, withdrawn by the California Office of Administrative Law. Then it got rewritten and put up again. And so finally in 2014 it got approved. And so it's a great piece of regulatory effort that really horrible about it. So all these people who are signing up now south of the Eel, they're all required to provide a minimum bypass flow. If you have an existing water right, you are not affected by the policy for maintaining in-stream flow. And really the only backstop on, you know, not dewatering a stream is either depriving a downstream water right holder of a senior water right, or Fish and Wildlife going out and saying you're, you know, resulting in unauthorized take of a listed species. And that's a pretty, you know, while we know it's all happening, it's a whole other matter to get that through court and to actually get the enforcement on somebody who's, you know, basically killing off all the salmon and steelhead that we've spent most of our careers trying to conserve. And so we realized is that, you know, if we could make this tool, it would make better monitoring of 3D listed water bodies more economical. And so not only, you know, I started out as a water quality nerd. I think I'll always be a water quality nerd, but mostly interested in terms of how it affects fish and aquatic habitat. And so I think it's important for us to look at these pollutant indicators, and the models we're going to deploy in the Delta in June. So they have, we're looking at conductivity, which is basically a surrogate for selenium coming out of the San Joaquin agricultural tailwater discharges. Looking at water temperature, dissolved oxygen. We're also going to use a infrared non-contact thermometer and see how that correlates with the immersed temperature probe. And so, so this is our solution. And so, one, we wanted to make that main compliance with a policy for maintaining in-stream flows. We wanted to make that feasible and doable. We wanted to be able to, as Bob said earlier, sequence diversions. And so, you know, if you've got 5 diverters on a given stream, and they all have our technology on them, then it talks back to the network. Our computer grinds the numbers, figures out, okay, what is the allowable diversion for today, sequences those diversions. If the capacity of a diversion, so let's say a creek can support a 1 gallon a minute diversion, but the water right holder has a 10 gallon a minute pump, then we have the ability to pulse that pump. And so we can pump for 1 minute and off for 9, pump for 1 minute and off for 9. And so this kind of gets us to the ability for these people who do have riparian rights, who, you know, their domestic water is reliant on a spring, but it gets them to a minimum harm, you know, harm minimization mode. And and then on top of that, you know, once you've got our device hooked up to your system, we're basically maintaining a database of diversion. We've got a number of features that we haven't implemented that are in the custom printed circuit board I showed you earlier. And so we can put tipping buckets out there and look at rainfall. We can put flow totalizers and count pulses, and kind of like your smart meter for your electricity and gas. We can do smart metering for rural water diversions. You know, create the backbone of a network that we can festoon with all kinds of neat water quality monitoring probes. We can start looking for blue-green algae. We can do a lot of things. And so, you know, so obviously we're able to measure stage. That takes the stage-discharge relationship. The nice thing about that for us is we're looking at the low-flow stage-discharge relationship, and so we're not quite so wound up about getting across the stream when it's, you know, raging at its, you know, Q10 or Q25. So, you know, our stage-discharge relationships are much easier to obtain than a full hydrologic cycle. Temperature, which is, you know, in my mind, I think to most people's minds, is kind of intricately married to inadequate in-stream flow. Conductivity, so down in the San Joaquin, they have this salty tailwater. That resulted in a thing, environmental disaster called Custerson National Wildlife Refuge. And so now then, after the courts have been through everything, the irrigation districts down in the San Joaquin Basin have to monitor how much salty tailwater they're returning to the San Joaquin versus how much fresh irrigation water they're diverting. And they pay a guy at Lawrence Berkeley Labs to run a computer model. And so, you know, he's using conductivity, but it's really just a surrogate for selenium. And in our case, we think we could do it real time. So he gets to refresh his model with reality once every 2 weeks. We can refresh reality every 2 minutes. Cyanobacteria, that's something that never used to happen back when I was a college student. And I think it's tremendously an artifact of all the phosphate that gets imported into these coastal watersheds because of our thriving agricultural business. And, you know, most of the phosphate in these systems swam back upstream, you know, 50 years ago. And it was a very complex form that took months and years to get incorporated into the ecosystem. And now that we're dumping it in a 100% soluble salt fertilizer solution. And, you know, so I think that a lot of these more recent algal bloom problems are just a function of mass transport of phosphate into the watershed, and it's got to go somewhere, and so it makes it into the groundwater, then it makes it out of the base flow. The other thing that'd be really fun to work with would be attaching a pit tag array to our device, and so you could have these things out there, and so you wouldn't even have to go out and download a data logger. You'd get this data sent back to you. And pretty much anything else that can be measured colorimetrically or with a sonde, if it can come out electrically, either analog, pulse width modulation, or serial, we can write it into our stream of data we send back, and you know, that gets us where we want to go. And so this makes diverters' life a little easier because they don't have to worry about illegal diversions and habitat destruction. If we really put these things in strategic low-flow barriers, we could make sure that we were maintaining aquatic habitat connectivity throughout the summer season. Makes the compliance monitoring reporting super easy, and you get this ability to not only measure low flow with very fine temporal and spatial resolution, but all the other water quality indicators that kind of combined with low flows to make bad conditions for juveniles. So the backbone of it is it's been programmed and doing it myself. I have a 50-year-old in plastic brain. Learning C++ is pretty hard for me, so we ended up hiring a really good programmer to do the majority of the work. And now then we're working on developing this tamper-resistant and somewhat hardened piece of equipment to send out in the field. Where possible, we're relying on existing cell networks. And it's not actually a full-on cell phone bill. So there's, you guys might have heard of the Internet of Things. There is now a series of devices out there that use a cell phone SIM card, but the subscription is way, way less than, well, it's a third less than a cheap cell phone bill. So about $12 a month to connect one of our devices to the Internet. And it's just because it has really low bandwidth. We're just sending little packets of data back and forth on a periodic basis. And we do know there's locations where we won't have cell coverage, and so we've got a contingency to work with a couple of other technologies. One's called low-powered wireless wide area network, and then also one called XB modem. And they both work on one. The XB gets 23 miles of line-of-sight communication via radio, and then the lower WAN it'll get 28 miles. And of course, we got to maintain proper IT security. You guys all work for the government, or most of you do, so you understand that drill. So that allows us to alert downstream users of adverse water quality conditions. So one of the things is we're looking at trying to partner with Humboldt County to do some of the blue-green algae monitoring. We're pretty confident there's a fellow at EPA that's able to detect blue-green algae from satellite photographs from outer space. And so we're pretty confident that we can detect blue-green algae from a camera or a color sensor, somewhere, 5 to 30 feet above the wetted channel. The initial capital expense of that backbone will get paid for by the water diverters. And, this instrumentation, like I said, will get us to where we can look at, what is affecting cell monitoring success, and, is it water quality, water quantity, or, as we both all expect, I think, is the synergy. So we can graphically show these trends. We wanted to make it so it's searchable data. So for the time being, we're going to be the data repository. We had tried to get a project funded where Humboldt State would be the data repository, but we were not successful in that grant application. So all this you've seen is really just an investment of Bill and Danny's money and some of my money and my time. And so, we think that also better information about things that are affecting the watershed can result in public education and abilities that we just don't have right now. And so we're going to deploy right alongside 4 Department of Water Resources, California Department of Water Resources stations down in the Delta in June. That's a tremendous opportunity for us to be right next to, these stations that cost the government many tens of thousands. For us, we think that once we've kind of got the software bill amortized out, once we get the software bill amortized out, then we'll be down in the $600 to $700 range, and so and we're really going to be testing our reliability and durability right next to these DWR-owned stations. Then we need to work on our software. I was up quite late last night trying to get a working time series, and it's just because the AT&T coverage at my house stinks. So Delta Water Master, everybody says Verizon's a better option for down in the Central Valley. So we're gonna, port our device and our application onto Verizon's network, and we still have to develop the web hosting and archiving processes, and then also work on this interoperable diversion control. And so if you have any questions, feel free to call us. There's our numbers. Bob has all my contact information. Now I'm just going to show you a little bit of the website, how it's connected, and so this is actually semi-real time.
And just so you know, as he's pulling up these websites, I started recording this webinar actually 2 slides late, but anyways, it's going to be it's going to be recorded, and I can send it out to the group as well.
So now you're looking at the AT&T M2X service. So this is a bunch of test data. This is the past 12 hours of data. And so you can see I turned it on yesterday evening, filled up my bathtub, and then let it drain out, filled it with hot water, and then let it drain down. And so that's what you're seeing this rise and drop of about 1.5 feet, 2 feet of water in my cutting edge testing facility. And then water temperature. And so you can see I started out with some really, really hot water and let it cool down over time. And here we are, and it'll give you the value. And so this is just a tiny, set of the things that we're going to be measuring. So we'll be able to, like say, count pulses from a flow totalizer, put that into a daily value. We think that by looking at both power coming out of the photovoltaic panel and looking at how much of the characteristic wavelength of blue-green algae, we think that those two pieces of the data will allow us to kind of predict the presence of blue-green algae. And then here's our site. This kind of shows just that same set of data. It shows that it's really easy to take that information. So what we would expect. So you can take any of this data and move it anywhere you want. You can also download this data, and so let's say we want to get the water temperature. We can give it a data export and tell it what time we wanted, how many values to export. We've got a number of charts, so let's easily go back to here. And so nonetheless, this is where we're at. Is we've got a really nice piece of hardware that is really using cutting-edge technology. The thing that kind of forced me out of the BLM, well, a couple of things. I wasn't happy being a field office engineer for the duration of my career, and so I had this idea about this device, and Bill and Danny kind of recruited me to PWA. But the thing that kind of broke my back at BLM was this robot actuated gate out at the South Spit. It'll get vandalized on like once or twice a week basis. And the guy who built it, he was pretty good, but he didn't really have the greatest experience in marine electronics. I got out of high school in 1983, went to University of Texas for a year, didn't really know what I wanted to be, so I joined the Navy, became a periscope mechanic. And so it turns out the periscopes are stuffed with electronics. We used to call it the $18 million ice pick. And so I've got pretty good experience dealing with marine electronics, marine air. So our device has both the internal temperature and humidity sensor, so we can see if condensation is about to start, see if our desiccant packages have done their deal, go out and rescue that device before the humidity gets so high that it's going to cause damage to the electronics. We've got the ability to look at power production, look at how much juice is in the battery. So we're trying to make it so it's a very reliable and has good kind of internal health monitoring ability, so we can get out there and work on these before we turn them into a paperweight. So anyhow, that's the bulk of my presentation, and I didn't entertain any questions.
Could you talk a little bit about costs?
Oh, sure, yeah. That's the most important thing, actually. So costs. So the special little module, that's $119. The sonar is about $109. The immersed temperature probe is about $10. The IR sensor is about $19. So the time it's all bolted together and ready to go, the hardware costs, and the thing that really runs up the cost is as you would expect, the conductivity, DO. But those are still pretty affordable. So our conductivity probe is about $220. DO probe is about $300. We plan to be out in the Delta servicing those every 2 weeks, just because we know that this gear that's in the water is going to grow algae. I've done a fair amount of this other work at the water board. But yeah, so we're looking at kind of a full package price, especially once we've kind of amortized out the programming costs, so somewhere around $800. And so we think that's attainable. especially for people who, don't have to pay a water bill, and, the potential penalties from the water board for violating their water rights are relatively significant. And we would maintain this, pretty bulletproof record, held in a, third party's hands that would show that they were in compliance with their water permits. And then finally, so we want this to become an open sourced effort. I, having worked in the regulatory world, having worked for the federal government in the resource conservation world, worked in the consulting world, I don't think anybody's regulatory life or death should hang from a proprietary thread. And so what we want to do is we want to make this widely available. Obviously we still need to, we're a business, so we have to pay salaries and keep the lights on, but we really want this, we think that the greater value than just the hardware is the data that's going to come from it and our ability to ask some really fascinating environmental questions.
Okay, well thanks Brad, really appreciate that. I'm sure the folks on the phone have quite a few questions. I see actually a couple other people have joined since Brad started talking. Jennifer Bull, and then who else? Who else joined before the intro? Just Jennifer Bull? Okay. Anyway, so we can start our question and answer period. Does anyone have any questions?
This is Tricia Bratcher with the Department of Fish and Wildlife in Redding. How does this compare, say, to SCADA equipment? I don't know all what the acronym stands for, but we have some water diverters over here in Tehama County that have installed SCADA equipment on their diversions, and it sends a signal back to a computer in their office telling them what their rates of diversion are, and if they ever have any drops of flow maybe caused by a log or debris jam or something, a signal comes up on their computer, so then they know to go out there and deal with it. As opposed to
so SCADA is computer automation and data analysis for most municipal water plants, most municipal wastewater treatment plants are fully equipped with SCADA equipment. And so we're very similar to that. We just want to be SCADA that's economical on the individual diverter scale. SB 688 requires anybody who diverts more than 10 acre-feet of water to, do daily measurements of diverted volume and, receiving water conditions and all of that. So this is very, very similar to a SCADA system. It's just a SCADA system is going to cost you in the $50,000 to $100,000 range, and like I say, we're trying to keep our hardware costs under $1,000. And then these do have to be installed by somebody who knows what they're doing. So there is some installation costs associated with developing the stage discharge relationship. But yeah, they're very similar. Ours is just an order of magnitude cheaper.
Any other questions for Brad? No more questions? Come on. One thing that really kind of stuck out for me was the relative low cost of these items. So apparently it's about somewhere $600 to $800 depending on whether you want the Cadillac or the Pinto. It's a $12 a month fee for your internet and your connection through the cellular technology, and then the maintenance, depending on how how much algal growth is in the system, that typically runs from what?
Well, so that's a function of having sensors in the water. So we're thinking that in most of our locations, so this was really envisioned looking at the problems in northwestern California and illegal diversions. And so most of our systems are small enough that they don't get thermal stratification. So that's why we've got the infrared contactless temperature sensor. It's quite accurate, but it just gets the surface temperature of the water. It doesn't actually get the depth at the bottom of the pool or anything. But most of our streams are pretty well mixed. Once you get into bigger systems, and the other thing is, we need to be located somewhere above the channel, ideally, smack dab above the thalweg. So that kind of means that applications for us in big rivers like the Scott River, that would require us either to be outfitted on a bridge or on a piling in the river. So we do have limitations. We're really looking more at headwater streams, but that's really where the most of the, at least in the coastal part of Northern California, that's kind of where most of the fish action happens, and that's where most of the water quality degradation has its worst impact.
Then you mentioned something earlier, Brad, about the cost of the software. So let's say you set up a network for coordinated diversions, like let's say you want to put them on 8 or 9 different diversions in Freshwater Creek. So the software, you only have to buy one software package for the entire network to work. Is that correct?
Yeah, so you don't even really need a software package. So Embed is open source. So once you get your device and your device ID, you can take and create all the graphs you want here. You can also create alerts, so it can send you an email saying that the stream stage has dropped below some level. The other thing we're looking at is, there are a lot of people here who've spent, quite a bit of money on storage and forbearance. A lot of them are what are called ungaugeable siphon flows, so they've got some straw in the creek that's, diverting by gravity into a tank. It doesn't have enough head to spin a flow totalizer, so they have a really hard time gauging these small diversions out of springs. However, if we instrument their tank or tanks with the sonars, then we're able to see how quickly water is filling up the tank, and so we're actually able to give them, we're able to gauge what were previously ungaugeable flows. So did I answer your question?
Yeah, but the software package also costs money, right?
Right. So there's somebody to operate that. So we haven't developed the database that parses out who gets to divert when and where. But certainly right now, without any additional money, you can set up triggers. And so once the flow in a river drops to 15 times the mean annual flow, then you'll get an email saying, okay, yeah, might be time for you guys to start, considering, ceasing diversion. I think the in-stream flow policy is it 9 times the mean annual flow, 10 times the mean annual flow is your cutoff, and so that just gives us the ability to alert people that currently, without any additional software, individual diverters can be notified when they're going to violate the in-stream flow policy. We have not developed a database yet that's going to go out, grab these data, crunch them up for a given watershed, and then spit back out a diversion control. But that's something that's well within our capabilities. One of the things I did at Region 2 is I and a contractor wrote the very first application that allowed the wastewater treatment plants in the Bay Area to send in their monitoring reports electronically in an Excel spreadsheet. And the thing that's really cool about that is, they'd mail their stuff in, the computer would wake up at midnight, digest it all in, send an email to the responsible regulator saying, the San Jose wastewater treatment plant submitted their report. They had 2 violations. But the thing that was just so incredibly valuable was actually the database. And so you had never, before that database existed, been able to go and ask how much mercury went into San Francisco Bay in the last, in 2010. That was just not an answerable question because it was all paper records and impossible to plow through.
Thanks, Brad. Any more questions for Brad?
This is Tricia Bratcher again. How applicable do you think this might be in more mountainous areas where at least existing cell phone coverage would be spotty to non-existent, as compared to, say, using a spot phone, which seems to have a little better luck in some mountain areas, but not necessarily?
Yeah, and those are pretty spendy too.
Yes.
So in areas that have no cell phone coverage, we've got 2 options. So we can either add on a data logger and log it on to a SD micro card, and those things are up to 64 gigabytes now, and so you could leave the thing out there for 5 years and not fill up a 64 gigabyte card. So There's either, going back to a kind of traditional data logging ability, or like I said, to implement either the low raw WAN system, which is a radio-based system, or the XBA radio-based system, and radio that stuff to a site that has can get in touch with the cell phone tower. Yeah, we can do all the data logging right inside of the device. It's just you got to physically go out and retrieve it.
And those ranges you said were 23 and 28 miles, respectively, for those different opportunities.
Yeah, and so we see a couple other really interesting applications as well. So one would be frost suppression water or frost control water. We could easily instrument vineyards. So we've got leaf wetness sensors which exist, and very good resolution thermometers, and so you could have these spread throughout a given watershed. And then the water goes only to the places where frost is incipient, and so the people up on the hill have the first access to the water, but they're not really the most frost prone because most of that cold air tends to pool in the bottom of the valley. So, we could get to a spot where we have this, precision farming approach to frost suppression water, and make sure that the people who need it the worst get it, and also make sure that the fish don't completely get left out of the calculus there.
Would you say perhaps that this might be a way to, say, replace something like a pressure logger, pressure transducer system? We have some installed in our upper watersheds, so they're in there 24/7. We have to download them, and they're in there during year-round, so subject to all flows. But I'm wondering how if that what you have might replace something like that?
Well, that's why the DWR and USGS are kind of fans, is because they realize that the problems associated with having gear in the water are just very expensive. Pressure transducers themselves, you can spend more on a pressure transducer than it would cost for our entire box. And then you're not guaranteed that pressure transducer is going to still be there when you go back out to look for it after a big flow event. So yes, we do see ourselves, not necessarily replacing them, because there will be, locate situations where the pressure transducer is a better option, But Onset now has a Bluetooth pressure transducer that you set in the foul weg, and then you run a little wire up to above the water surface. And so in the parlance of microcontrollers, Arduinos and Cortex M4 stuff, it's called a radio, and it doesn't matter whether it's an XD radio or a Bluetooth radio or a cell phone radio. They all kind of behave the same way. It's just a little bit of custom coding to go between the two. So we don't see ourselves as completely replacing the pressure transducer, but certainly the agencies down in the Delta, and they're mostly concerned about stage, so if we can get the data they need via stage and infrared contactless water temperature, and we don't have to have any gear hanging in the water, I don't think we'll be going out and doing any service other than wiping the crud off the photovoltaic panel every now and then.
Thank you.
Any other questions? I know Margaret Towser has been thinking about this for a long time. Any questions from you, Margaret? Sorry to put you on the spot.
I've got a quick question. This is Lindsay from the Siskiyou RCD. I'm a little bit unfamiliar with the sonar that you're talking about for measuring stage, and it is out of the water?
Correct.
Does it need to be like completely overhead then, or how does that work?
So if you can see the cursor, the little horn-shaped thing is a sonar, and it sends out an ultrasonic pulse, measures the time of travel for it to go down, hit a surface, and bounce back up. It's got some nifty electronics, built into it, so it sifts out like limbs and things that don't have a really large, don't have a really big ultrasonic return. and it will, filter out and get just the water surface. So yeah, so you do have to be somewhere either, over the thalweg or close to the thalweg. But that's doable in a lot of locations where we can instrument from bridges. It's also, we could, basically screw these onto channel spanning logs if you're in a, steep mountainous terrain and you got a, if you got a log there, and then you can see we've got a really long cable to get to the photovoltaic panel, so we can move both the sonar and the photovoltaic panel to where it works best. So, we can take the sonar off of the box, conduit that wire back to the box, have the box sitting somewhere where there's best cell reception, and have the photovoltaic panel sitting somewhere else where there's the best solar availability. But yeah, so it's like I say, it's been used many times. There's a back in 2006, Iowa had a series of really humongous floods, and so 2006 or 2007, University of Iowa came up with a thing called the Ultrasonic Stream Bridge Sensor, the USBS. And so their gear is about, I would say, 10 times the size of ours, but it does exactly the same thing. In their case, they're looking at hydraulic capacity of bridges and trying to find out those bridges that are most at risk of getting debris jammed and blown out, and trying to prioritize, replacement of bridges that don't have adequate hydraulic capacity. But this exact same technology has been deployed with in Iowa now for going on 9 years.
Interesting. Thank you.
More questions? Okay, folks. Well, a big thank you to Brad and his presentation. I'm glad there was this much interest in it, and I'll be sending out. Can I send out a PDF of your presentation?
You bet.
I'll be sending out a PDF of the presentation plus a copy of the webinar that I accidentally started 3 slides in. But anyways, thank you very much, Brad, and thanks everyone on the phone for participating.
Yeah, we have the parts, almost all the parts on hand to assemble 10 of these. So 4 going down in the Delta, 1 more, we have a location for it, but we're definitely looking for partners. This has been all internally funded by PWA, so it's not like we've got huge amounts of time and money to throw around, but we are really looking for people who have, either these, critical low flow fish passage issues that, would have a really high return on investment, or these, critically over-allocated basins where we've got willing landowners who are willing to host our equipment. That is the other thing about my time at the BLM, is realizing that almost anything that's put out in the middle of nowhere and not attended to for a while will get shot at or stolen. So we do worry about site security, and these represent a pretty large investment on behalf of my company, but we want to find cool places to put them so we can answer some interesting questions and get the technology out there. So, like I said, we're more interested in fish conservation than in selling electronics, but if electronics get us there, please give us a call, and we'd love to work with you.
Okay, thanks everyone. Look for a follow-up email from me. Enjoy the rest of your week.